Okay, we're on to our class. Mamu with Jarvis, and we're having a live session, and we'll be looking at an aspect of geometry that talks about angles in a polygon. Two keywords we need to take note of them: angles and what? Polygon. We are well acquainted with what an angle is. We said that an angle is the separation between two lines that are intersecting, joining, or what? Meeting. We will try to have that pictorially. Lines intersecting, lines joining. So what you have, letter A to F are what? Different angles. And our focus will not be on angles per se because we've done an extensive work on angles. Our focus today will be on this aspect of the discussion: polygon. So what is a polygon? A polygon simply is a closed plane. Let's take them in that order. So what's a polygon? Let's take them in that order by looking at the keywords: closed, plane, it is closed, straight or lateral sides. A polygon is a plane closed figure with what? Lateral or straight. The word lateral and straight mean the same, but there's one other important thing you must take note of in a polygon. The number of sides of a polygon must be at least 3. Reason being that if a polygon has less than 3 sides, it becomes difficult for us, for the figure to be what? Closed. So it will be important for us to talk about types of polygons. Types of polygons. So let's start with the simplest polygon. The simplest polygon you can ever have is the one we call a triangle. A triangle is the simplest form of polygon you can have because a triangle has what? 3 straight sides. Okay, so this is a triangle. The next we want to look at is what is called a quadrilateral. Quadrilateral will be a polygon that has what? 4 straight sides. And then we can go on to talk about things like pentagon. You have to go along to talk about pentagon. Pentagon, hexagon. So for a pentagon, we imagine 5 sides. For hexagon, you have 6 sides. And then you have something they call heptagon. Hepta means 7. And then you have something we call the octagon. Then we have something we call the nonagon. And there's something we call the decagon. So we start with a list, 3 sides. We come to quadrilaterals, we come to pentagon, we come to hexagon, we come to heptagon, octagon, nonagon, and decagon. There are lots more you can look at, but for now, let's stop at 10. So let's take note of that. This is the central idea of this topic: the sum of interior angles of any polygon. Prior to now, students try to memorize this, try to cram. That's the word we sometimes use, colloquial English though. It's not necessary to cram in maths. It's really not necessary. Once you have a strong grasp of the concept, it becomes easy for you to flow with the idea. Now, the least polygon we have in mathematics is what is called the triangle. So let's look at something. We're going to be drawing a lot now. This is what the triangle looks like. How many sides? 3 sides. They're not. Now, you have been told before now that the sum of the angles of a triangle is what? 180 degrees. You must look at that. The sum of the angles of a triangle, or the sum of the interior angles. Let's be more technical as to the sum of the interior angles of a triangle is 180 degrees. Please pay close attention to this, because this is what I'm going to use as my building block to help you get any other polygon, any one at all. Once you have this understanding, you can tell what it is. Alright, so that's for a triangle. I'll give you some time to draw that and then to write in short notes. So we come to the next shape, and this is a quadrilateral. I am just picking any one. This is a quadrilateral. Just picked any quadrilateral at all. 4-sided figure. And we know that the sum of the interior angles of a quadrilateral is 360 degrees. Sum of the angles of a quadrilateral is what? 360 degrees. Now this is where I need you to pay very close attention. I can divide this into 2 triangles by cutting through what is called the diagonal. A diagonal is a line that cuts a shape into 2 parts or 2 or more parts. But it cuts it, what it does, what the diagonal does that it touches opposite sides of the figure. So if you look at this, this becomes one triangle. This becomes another triangle. This one triangle, this another triangle. What is the sum of the angles of a triangle? 180. So how many triangles are you seeing? So it means that the sum of interior angles of a quadrilateral is equal to 2 times the sum of a triangle, 2 times the sum of the interior angles of a triangle. This is a basic idea you must keep very well, because this is the idea I'm going to use to open up this mathematics multiverse. Okay, we've been able to establish that for what are the conclusions we can draw from this? Let's watch. For a triangle, the sum of the interior angle is 180, and it's just one triangle. For a quadrilateral, you have 2 triangles, the sum being 360, and the sum of the quadrilateral, the interior angles of the quadrilateral, would simply be what? The sum of 2 times that of the triangle. So it means that every quadrilateral would have how many triangles? 2. Please follow me closely. Now let's see what a pentagon holds for us. Let's see if we can recognize what a pentagon looks like. Let me see if I can draw a pentagon. So this is what a pentagon would look like. So we'll call this a pentagon. And a pentagon has what? 5 sides. So let's cut this pentagon now. You cut from a fixed point here. So what you're going to see is triangle 1, triangle 2, and triangle 3. So you have what? 3 triangles present in this pentagon. So the sum of interior angles of a pentagon will be equal to 3 times the sum of interior angles of a triangle, which will be 3 times 180, and that will be 540 degrees. I see that. So the sum of the interior angles of a pentagon will be what? 540 degrees. How? Because by my diagram, I know I have 3 triangles. Alright, we'll go to another level with this. Polygon type, number of sides, number of triangles, sum of interior angles, sum of interior angles. Alright, so let's continue. The first type we look at is called a triangle. The number of sides will be 3. The number of triangles will be 1. The sum of triangles will be what? 180 times 1, which will be what? 180 degrees. The next one is a quadrilateral. I should open up this part a little more. Let's open up this part a little more. Number of sides. So quadrilateral. Quadrilateral. This will be 4. Number of triangles 2. 180 times 2, that will be 360 degrees. Number 3, pentagon. Number of sides will be 5. Number of triangles will be what? 3. The sum will be 180 times 3, that is 540 degrees. So go to the next one. Hexagon, hexagon, hexagon 6. Number of triangles will be 4. Are you noticing something? 1, 2, 3, 4, 5, 6. I seen it. You have to be sharp in your thinking. Sharp. Try to study pattern. Try to study pattern. So this will be 180 times 4 equal to what? So you do that and give us the answer. This will be heptagon, heptagon. Now be 7, this will be 5, this will be 180 times 5. Now let me do a little explanation here. If the number of sides is 3 the number of triangles will simply be what? 3 minus 2. The number of sides is 4. The number of triangles will be what? 4 minus 2. The number of sides is 5. The number of triangles will be what? 5 minus 2. If the number of sides is 6, the number of triangles will be what? 4, which will be 6 minus 2. If the number of sides is 7, the number of triangles will be what? 7 minus 2, and that will be what? 5. I see what's happening. We did that by showing this. See, from 3, you had 1. From 4, you had 2. So it means just keep subtracting 2. And by the time we come to the formula, you begin to see how that formula plays out here. This will be 720. 900. So the next one will be octagon. Octagon. That will be 8 sides. 8 minus 2, that will give us 6. 180 times 6, that will give you 1008 degrees. And then we have nonagon. That will be 9 sides. And that will be 7 triangles. So please take note of this table because you could be asked in the exam how to handle this. Times 7. And that will give me something in the neighborhood of 1,000 and then 1,260 degrees. And then we have decagon. We usually will stop at decagon. It's safe to stop at decagon at your level. But there's ondecagon, there's duodecagon. You choose to want to expand your learning. But at your level, decagon will just be fine. That'll be 10, that'll be 8, that'll be 180 times 8. And that will give us 8,440 degrees. Having done this, let's now assume we have n-sided polygon. So what is the formula? None of us would like to have formula. If it is nth polygon, the number of sides will be n. The number of triangles will be n minus 2. And the number of triangles will be what? 180 times n minus 2. Which will now give you what? What will this give you? This will give you 180n minus 360. Let's leave it at that for now. Because as we proceed in this topic, we'll begin to expand our idea of this concept. Okay, we'll try to use our knowledge of this topic to answer revision test 6 of our textbook, looking at page 45, Nigerian Mathematics for JS2. And then the question says, how many sides does a polygon have if the sum of its angles is what? 18 right angles. I'll come again. How many sides does a polygon have if the sum of its angles is what? 18 right angles. The first question you want to answer is this. What is the value of one right angle? So you start exercise revision test 6. That will be question 10. The first thing you need to take care of is one right angle is equal to what? 90 degrees. That's the first thing you need to take note of. The next thing you want to take note of is if the sum of its angles is what? 18 right angles. So 18 right angles will be equal to 18 times 90. So 18 right angles will be what? 18 times 90. Let's write this off the board so we don't get confused. 18 right angles will be what? 18 times 90. Now, Remember that the concept of the sum of interior angles is a concept of the number of triangles. So 18 right angles, so number of sides will be equal to the number of right angles plus 2. Okay, but let's go back a little. Let's take this little by little. Some of us might be able to. So the next thing now, the sum of interior angles of polygon, sum of interior angles of polygon will be equal to 18 times 90. That one is settled. The next thing we'll need to look for now is the number of triangles. So number of triangles will be equal to what? 18 times 90 divided by what? 180. So we cancel that. I'm going to have 9. The number of triangles is 9. But recall something very important, that the number of sides, the number of the sides is equal to what? The number of what? Triangles. The number of sides is equal to the number of triangles plus 2. Remember, if we remove 2 from the number of sides, we get the number of triangles. If we remove 2 from the number of sides, we get the number of triangles. So, if the number of sides is what we are looking for, what is the number of triangles? 9. Plus what? 2. So, this figure has what? 11 sides. And technically, we are going to call this what is called undecagon. 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 U-N-D-E-C-A-G-O-N. Undecagon. So that is the shape the polygon we are considering. Now, if the polygon is regular, what is the size of each angle in degrees? In our next class, we're going to look at what it means to talk about what? Regular polygons. So we'll sign off for this moment and then trust you go back to do your relevant revisions. Thank you.